I'm going to go ahead and introduce Patrick. If I can find him, one moment, please. And with that, it is my absolute pleasure to introduce Patrick Warichet, who is the Principal Product Manager here at Palo Alto Networks. And Patrick, the show is yours. I will let you take over the screen control, sir.
Yes, thank you so much. Thank you for the introduction. My name is Patrick Warichet. I'm a Principal Product Manager here at Palo Alto Networks. I'm responsible for the design of everything that is related to clustering and routing in general. So today I'm going to present you two sessions. One would be centered around clustering, and we would talk about the new exciting clustering features that are coming with the new generations of firewall. And then after that, I will present you the advanced routing engine that we have leveraged a year and a half ago, and give you the advantage of this advanced routing engine. So with that, let me try to share my screen.
You're good.
I'm good. All right. So it's appearing different a little bit here. So, okay. So before this session is about next generation firewall clustering. This is the official name of the new feature. This is going to be leveraged with the new platform. We call it the 700, PA7500. And this platform leverage a new ASIC. So this is internal developed ASICs. This ASIC, we refer to it as the FE400, has extreme low latency and extreme performance. Is capable of doing 400 gig of interface support on a single silicon, and overall can boost the chassis capacity up to 1.5 terabit with AppID inspection. If you want to do threat inspection, you are at 1.4. So this chassis is also a modular chassis. It's a 9-slot chassis, net compliant, and its use cases, of course, high-end private data center, large campus edge, multi-site interconnect, and of course 5G protections and data inspection. So this firewall, as it is modular, we will see also that it has 3 types of line cards. It has an NPC, a DPC, and an MPC. I'm going to go over them in the next slide. Essentially, the chassis is capable, at the minimum, you need 1 line card. So compared to the 7000, which this platform is replacing, we have the disconnect between the NPC and the DPC. So the DPC does not have any connections. It's purely for compute. And the NPC only has the network interface.
Sorry, my apologies for interrupting here. We're having a little bit of problem with your audio. It's kind of cutting in and out a little bit. Can you bring the mic a little closer to you?
Oh, of course. I'm so sorry.
No worries. It happens. It always happens on a live event. So just wanted to let you know.
Is this better?
We'll let it go for a little bit. I'll let you know if there's any issues. Thank you.
Okay, thank you. So the chassis itself has 1 NPC. As a minimum, you need 1 NPC, 1 DPC, and 1 MPC. Right? That would give you already 800 gig of network I/O. And around 310 gig of application ID identification. That is the bare minimum for the chassis. Now, if you want to fully populate it at maximum capacity, you need 2 NPC, 6 DPC, so that's a lot of compute, and 1 management interface, right? So that will give you 1.5 1.5 terabit of AppID, 1.4 terabit of threat inspection, and about 440 million consecutive sessions. The capacity of the system at that point is 2 billion sessions. So, but simultaneously can only handle 440. And when I say only. That's quite a lot compared to a previous generation. What is important here, and I'm going to let you read the numbers by yourself. It's not really the subject of introducing this new chassis here today, but more talking about the clustering solution. It has on the MPC, which is the management card, has 2 dedicated HA interface. And those interfaces is capable of running at 400 gig each and support MACsec encryption. So here is basically the breakdown of the line card. What is important to note is the NPC line card, right? The DPC does not have any interconnection, so no front panel ports. On the NPC, you have 8 QSFP, can do 400, 140, and 12 SFP-DD, which can go from 100 down to 10. You can install a maximum of 7 in a chassis. And the MPC line card, which is mandatory in the chassis, and that one has 2 QSFP-DD at either 100 gig or 400 gig. And then, of course, you have the fabric line card that go in the back in order to be NEP compliant. So let's talk about a little bit the FE400. And our new clustering solutions completely leverage the capability of this ASIC. Going forward with our Generation 5 hardware, the FE400 is the building block of that new generation. We have immense layer 3 for running capacity, 1 million FIB entries for IPv4, 1 million FIB entry for IPv6. We can do ACL, layer 2 MAC address table management 256K. We can manage 4 KSA for MACsec. And of course, it is the building block for our clustering support. Here's another view of the system per line card. On top, you have the MPC, the management processor card, with its FE400 and its HA interconnect. It has its own CPU memory. Then the NPC will have all of the front panel port, and that's where all the routing function will occur. That's where you're going to have your route lookup, your L2 lookup. That's where we're going to do QoS management. That's where the routing will happen. It has 2 FE400 on each line card and a processor with its associated memory and I/O. On the DPC, there is no external connection once again, but that's where all the firewall magic will happen, right? We have an array of 6 CPU with 20 core each. And we can do, that's where we're going to do decryption. That's where we're going to do policy-based forwarding. That's where we're going to do application recognition. That's where we're going to do all of our user ID. All of the magic of the firewall will happen at the DPC. Now, what the new FE400, what kind of clustering solutions are we proposing? And I'm going to go a little bit back here with some more recap. If you're probably very familiar with our 7000s and all of our Generation 3, the way we manage the different type of HA. You have 2 modes, active-active, and what happened in active-active? Active-active require 3 interconnect, HA1, HA2, and HA3 for the data plane, and both firewall in the cluster are active, both at the management level and at the data plane level. And they are synchronized to each other, although because they are independent management plane and control plane, there is a limited amount of information that we can synchronize. On the other side, the HA active passive, which is most of our deployments today, as I could, has the second firewall completely silently synchronized at both at the control plane level and at the management level. The data plane is also silent. It does not, it only requires 2 interconnection that can be provided by the HSCI port on certain platform, the HA1 and the HA2. Now, what the new clustering paradigm introduced, it will basically blend the 2 modes together in a single HA solution. What we will provide is basically an active-passive control plane, where the passive firewall is completely synchronized, both its configuration and state. But the data plane on the secondary firewall is fully active. It's controlled by what we refer to as the leader of the cluster. The leader can have one follower in this first version of the feature, and we will add more followers as we extend the solutions to a cluster of more than 2 firewalls. The interconnect is strictly done over the HSCI, which is 400 gig per port, acting as a primary and a backup. And once again, 400 gig with MACsec at line rate. So a little bit of recap here also about the legacy HA and the next generation clustering solution. On the HA, HA1, HA2, and HA3, HA1, HA2 can be redundant, are routable. Some of them support encryption, some of them don't. HA3 does not have a backup connection, and it's a single broadcast domain. So you must have them interconnect through a VLAN or an overlay. But it's a single broadcast domain, so you don't support routing. With the next generation firewall clustering, at this point in time, we have a primary and a backup, so a leader and a follower. Have both, we can connect both HSCI port, HSCI 1 and HSCI 2. One will immediately be elected as the primary and will be able to support MACsec. There's a star because the MACsec feature has just been released last week. We released 11.15, our latest release for this solution, which enable MACsec. So MACsec is now fully supported on this platform. It's also a single broadcast domain, so we do support directly interconnect if you want to do MACsec, or if you don't want to do MACsec, you can put a switch in between. Right? But as long as it's a single broadcast domain. So what do we do with this? So in clustering mode, both of your firewall will be merged together and become one logical firewall from the control plane and the management plane point of view, right? So our interconnections is only through the HSCI, and it operates more or less as a standby, active standby from the HSCI perspective. So only one link on the HSCI is active at a certain point. We cannot bundle them into a port channel. What we introduce as a secondary feature in order to increase the redundancy of the system is MCLAG. For those of you who do not know, MCLAG stands for multi-chassis link aggregation. The capability to create an aggregate Ethernet interface with member on both chassis. And we can only leverage this feature because now both data planes are active, but controlled by the leader, right? What is the advantage of an MCLAG? It acts like an aggregate Ethernet from the external devices. Nobody sees the difference that you are indeed in 2 firewall, but from external, it sees one ID from the LACP standpoint. And of course, LACP is supported. The advantage is we do not use floating IP. There is no need to support floating IP like in active-active, and you reduce the amount of address you consume for that. For example, if you want to do, and we're going to talk about this, IPsec termination on an active-active system, you have to terminate your IPsec tunnel on floating IP, which consume already 3 IP plus 1 for the tunnel. That's 4 per tunnel if you have lots and lots of tunnel. And this device can do lots and lots and lots of tunnel. It's a lot of IP address consumptions, which can be annoying for the operational perspective. It also reduces the amount of peer. If you are in active-active, you have to each firewall needs to peer in with a neighbor, whether it's OSPF or BGP. You need to do a peering. Here we reduce the peering because you can use an MCLAG and peer on the layer 3 over a port channel. Of course, way more load balancing capability, and 2 modes are supported in MCLAG, L3 mode and vWire mode. We do not support L2 in that mode, right? So the advantage, of course, of the MCLAG is that the failover time is extremely small, because if you lose by accident one link, the algorithm will rehash on the remaining link, and there would be no issue with layer 7 inspections, if that's what you want to do, the solution is actually completely done for maximizing L7 inspections. We're going to go over the detail of that in a few slides. But the failover time, if you lose one link in an MC lag scenario, is extremely small. Right, and of course you have way more power, port availability compared to an active passive, where all of your passive chassis ports is standby. We also preserve the investment you have done in our company by providing you all the chassis connectivity at the same time. Here,
we had a couple of questions come up. Do you want me to hold them, or you want to go through them right now?
I can certainly.
I can just read them off to you if you'd like. How many MAC addresses are supported on the MPC?
256K per MPC.
There you go. Next question was different IP addresses assigned on the corresponding L3 interfaces of leader follower as per AA.
No. That's exactly the thing that we are trying to resolve. A single IP address. If you do MC lag, if you want to do orphan port, which are port attached to a single chassis, and we're going to go over that in a few slides, then you have to have two IP address, just like in AA. Yeah.
Okay, fantastic. Adrian, I hope that answers your question. The first question was from David, so thank you for that, David. And then Javier is wondering, is this new feature only available for the 7500 series next-gen firewall? He asks because right now he's implementing a 5400 series, so it's a nice new feature.
That's a good question. Unfortunately, the feature is available on a Gen 5 hardware and beyond, but not Generation 4. The 5400 is Generation 4. So we cannot backport the feature. You need the FE400, which is not present on the 5400. Only the 7500 new platform will be released next year that will leverage the FE400 at the form factor of the 5400, where is a 5410, 5420. We're not going to do the modular 5400 at that point, but we will have a replacement for those platform, and they will have the FE400. So that at that point, the feature will be leveraged. Yes.
That's fantastic. Thank you very much. And by the way, your audio has been perfect ever since earlier, so we're good to go.
Okay. I'm really sorry for that.
Oh, please, no worries at all. Go ahead.
All right. So it's extremely easy to configure. If we have a little bit of time, I'm going to go over the process.
You were on the previous slide. I kind of started asking you questions on the previous slide in case there was something you wanted to mention there.
All right. Yes, that's right. So in this clustering mode, so the chassis have merged. Now, how do you differentiate the interface? They are preceded by the node name. So that is done when you create the cluster through Panorama. Panorama allow you to say, hey, which one you want to be node 1, which one you want to be node 2. When that is done, it will renumber all of your interface by node. So all the interface on node 1 will be preceded with node 1, colon, the interface, and all the interface of node 2 will be preceded by node 2. And then the interface. So node 1 interface 1/1 is different than node 2 interface 1/1. Right. So the complete solutions require Panorama in order to be managed. So you will have to create new template stack, device group, and of course you need the plugin to create the cluster. We provide the plugin. I mean, it's not a license, so you can have that immediately in your Panorama. You need the version 2.0 of the plugin in order to configure the cluster. Yeah, I know for the 1/1/1, I proposed that to engineering, but they wanted node 1 and node 2. I'm sorry. Yeah, we had a lot lengthy discussions when we did the design. But then you will see they refuse for a good reason. It's because you can put a breakout cable on the 400 if you want, or the 100, and then it would have been 1/1/1/1 because you add the breakout. And that was becoming difficult for several management applications, so we decided node 1 and node 2. In terms of routing, and of course there is another session about that. Just after this, it's only the advanced routing engine that is supported on this, and we could only do these solutions because we have the advanced routing engine available. It's extremely easy to configure. This, I'm not going to read through that. Essentially, you have to go to Panorama, enroll your 27500 at this point. More platform will be added. Create a new cluster job through the plugin. You need the plugin to do that. And then when everything's checked out, the plugin will verify for you. You commit, and then they both going to reboot in cluster mode. You get into commit and push, sorry. Then they're going to both come back in clustering mode. At first, they will appear on sync. And then after you create all of your device group and all of your template and template stack, the system will come back and then allow you to push configuration to the cluster. Strata Code Manager, SCM, is coming up to support the clustering in a few weeks or months. They have, I'm actually working with them to have that support added. Right now it's in beta, so we are testing it. Yes, you need Panorama to configure the cluster, Adrian. You cannot do it by yourself with the firewall. You need the plugin. The feature also come with what we call split brain detection. So split brain detection, for those who were familiar, is when suddenly you have lost connectivity between the two chassis, or the chassis are not able to see each other. So don't forget, the control plane and the data plane traffic go over the HSCI. You don't have a dedicated HA3. So the HSCI has been crafted in terms of QoS so that data plane traffic, so user traffic that have to go from the leader to the follower or vice versa, is requeued so that it does not impact the control plane and the management plane traffic that go over the same interface. We have 400 gig over there, so quite a lot of bandwidth to perform this task, but there is a QoS scheduling mechanism that puts all of the control plane and management plane traffic in a strict priority queue. However, if that HSCI would be compromised by a device in between, for example, or a failure of the transceiver, then the system will go over the split brain detection mechanism. That is done by the management interface. So each of the MPC will try to reach each other through their management port. So when you configure a cluster, we recommend or we enforce that you have the two management interface of both member reachable between each other, and you have a policy that allow the IP traffic to go from one to each other. Right? We have a very, I would say, complex state machine that managed the split brain detection mechanism and will essentially remove the follower upon losing connectivity after attempting first over the IFL, the inter-firewall link through the HSCI. That failed, you're going to try again over the management interface, and if that failed, the follower is shutting down immediately. So why are we doing this? We wanted to maintain forwarding capacity at 50%. Let's talk about the MCLAC, or the multi-link aggregation. What do we propose here? So essentially, this simplify your topology. This simplify your deployment. If you want to deploy this in a brownfield scenario or even in a greenfield scenario, and you want to interact with an Arista, or you want to interact with Cisco, Cisco has a technology that is similar called VPC, or Virtual Port Channel, and Arista is also a support for MCLAC or something similar. Cisco also support MCLAC, albeit in an active standby scenario, on the ASR series, high-end router. But what you do when you do this is essentially you have a physical topology that completely, almost full meshed the switch and the firewall, or the router and the firewall, but logically what you have is a single port channel connecting both entity. We support up to 8 members in a single aggregate and 64 aggregate over the cluster. Right now it's 32. 64 is coming up in 11.1.8. We do support a virtual wire and layer 3 interface. And we support local bias also. It's a feature that you may not be familiar with, that already exists, but has been redefined with this new technology. And the local bias is essentially the capability to egress the traffic on the node that performed the layer 7 inspection. And I'm going to talk about local bias at length in a few slides. Sorry. So what can you do? You can connect to a switch. You can connect to a router. If you connect into a switch, you probably, or even a router, you're probably going to do vWire mode or L3 mode. In L3 mode, you can connect, you can create your trunk, right, and have all your sub-interface terminated on the firewall. That is in L3 mode. This is the most common deployment for this solution. Fast convergence, of course, upon link failure. No need for VRRP, SSRP, floating IP. And also because you basically virtualize the two chassis into a single entity, you terminate on one IP address, it's very easy for IPv4 and IPv6. Floating IP with IPv6, or VRRP for that matter, or HSRP even, have a problem a little bit with IPv6 and NDP protocol, where you have some of the node that some of the neighbor will probably rate limit the amount of NDP. So if you do a failover, they may discard the NDP update and then black hole the traffic because they don't know the next hop. You can do multipathing with ECMP up to 16 path with right now 8, but we're going to increase it to 16. A multipath at layer 2 without ECMP. ECMP will still be limited at 4 path with these solutions. We do not change that. It's still the case today. But at layer 2 with MCLAC, you can have 16 link total with 11.1.8 coming up. And also I'm sorry, I forgot to mention, but in MCLAC mode, and if you want to do vWire, you can use an aggregate Ethernet for one or both of your interface in the wire, in the virtual wire. That is not, we allow you to do that, although we do not recommend to do it because it's you know, you can have issue with peering with other members, especially if you use LACP. But in this case, nothing prevents you to use an AE as an interface for a vWire. And that AE can be an MCLAC. You can have 1 or 2. Right, so once again, easy to integrate with other vendor. And that was kind of the goal here. I have a very long career with a major vendor of routing equipment, and we integrate completely with those solutions, whether it's a Cisco, Arista, or Juniper. And then also, because our technology is completely, working hand in hand with those, it really simplified the deployment. You can also have different type of redundancy if you want. So you can do redundancy to a single device, semi-redundant to a third-party device. For example, you do not have the bandwidth available to cross-connect the router on the second figure here in the middle, to cross-connect the router to the firewall. You can only do a single connection, and then you can still create a port channel if that firewall or router on the other side supports some form of link aggregation across 2 devices, whether it's VPC or MCLAC. And of course, it can be fully redundant, which is a traditional deployment scenario where you cross-connect everything. Right, so I talked a little bit briefly about local bias. Local bias is the capability to, when it's enabled, to send traffic back to the flow owner. Don't forget, a firewall is a stateful device. So it needs to be able to inspect all the traffic. And this, in terms of routing, which is always per packet, can create some form of issues. So what do we do? If the traffic becomes asymmetric, like you see, for example, ingressing on one, then going through the firewall and then having firewall A as the owner of that flow, and then ingressing A via 2, 3, reaching the endpoint there, and the endpoint due to ECMP or routing, whatever, go back through 4, then reach firewall B at 5. At that point, if you are in MC-LAC mode, local bias is enabled. The firewall B will identify the ownership of that flow on firewall A, will then send that traffic over the HSEI, and the full packet inspections, whether you want to do decryptions, whether you want to do threat inspection, will be performed on firewall A. But firewall A will then forward the traffic, if it has a capability, straight via 7. This is the case already if you do active-active. But you can also have local bias disable. And in case of local bias disable, the inbound traffic follow the same path. On the return path, however, firewall B send it over to firewall A for the packet inspection, but firewall A does not have a path forward for that packet. In this case, you can send the traffic back to firewall B for the routing, the final routing and rewrite of that packet, where it's going to egress over it. So that way, that is a new feature we have introduced. Like I mentioned earlier, we have increased the concept of the local bias by being able to disable it in certain circumstances where the traffic will not trombone via firewall A through firewall A and exit firewall B. This is great for routing because we are not breaking the routing. We keep the traffic also symmetric over in the network. So we are really a good player inside your network. Traffic come on one firewall, even though it's a virtual device and it can ingress on the other one, we will maintain the symmetry of that traffic when the local bias is disabled. Here is a little bit the flow of basically the state machine of the local bias decision. Let's have a quick look at it, but I don't want to go over all the cases. We're going to go over the traffic, come back asymmetrically on B, but is owned by A, and then you have enabled threat inspection. So you're going to say, is layer threat inspection is required and not complete? So it's required and it's not complete. Yes, is my cluster healthy? Yes. Then I use local bias. I exit via 6 and 7, right? No. My cluster is not healthy. We have raised a flag, and the condition for that unhealthiness of your cluster, you have lost one DP card, for example, or you have lost one network processing card, for example, or you are not in sync, for example. In this case, your software or your hardware may have a problem. So what's going to happen? Are you missing egress AE member? Yes, I'm missing egress AE member, but we define a threshold there as the minimum amount of a member you support in an AE in order to maintain the local bias. If you are within that threshold, below that threshold, you still do local bias. You exit via 6 and 7. However, you have no link on A. You have lost the egress port on A for whatever reason. Then local bias become disabled. You go via 6, you come back via 8, and then you exit via 9. Why are we doing this? We maintain layer 7 inspections at all costs through the cluster. Albeit, we consume more bandwidth on the HSEI, and that's a given. But we maintain layer 7 inspection. In HA, we have no choice. In the classic legacy HA via HA3, we had no choice but to drop the packet. So at this point in time, we do not drop the packet. We send it back to its destination. So this is what local bias, and this is the state machine of the local bias.